So now that we've mastered the law of sines, we're now moving on to the law of cosines. This is what we also use when we try to find any missing sides or angles in any triangles. When we take a look at this one here, there are two things that are going to happen. When I'm given all three sides, I will use the law of cosines. When I'm giving two sides and an angle that is not opposite one of the given sides, angle sandwich. We've talked about that before with triangle congruence. The law of cosines formula seems very complicated, but don't worry. A couple quick things that you'll be able to know. First of all, you are given this on every test. You are not expected to memorize it. And after you've done it a while, you see things make sense. When I'm finding A, the angle is A. If I have B and C here, I have B and C here. So when we use the formula, it turns out okay. Just like law of sines, you're going to need to solve the triangle. Step 1, each time we're going to use the law of cosines. Law of cosines can be very complicated, so as soon as step 1 is finished, we can definitely jump to law of sines, which is the easier of the two. And even if you didn't think it was before, you will feel like it is after we do these questions. Now, what we want to do here is we are able to figure out the side that's missing here because we have an angle and because we have two of the sides. So this is what I would do. I'm going to explain where I got my numbers. I'm just referring to this missing side as side A. Not for any particular reason, just what I chose to do. I've got B squared and C squared, and I just picked whichever one is here. It really doesn't matter the order because I'm squaring them and adding them. Doesn't make a big difference. When I look over on this side, I'm subtracting 2 times each of these times cosine of 43. It looks like it can be super complicated, but your calculator can do all of this work for you. When the calculator does all the work, we find out that a squared is equal to all of this. We need to make sure a is isolated, so we square root it. So 22.3 is my missing side. So now we have all three sides in an angle. So we now have an angle with the side opposite of it, which makes it able to do law of sines. So sine of 43 over 22.3 equals sine of theta, and I chose 32. You can choose 28, it really doesn't matter. You're just finding one of the other angles. Because we've done law of sines already, I'm just going to give you a second to look at the work. So we found out that the angle opposite of 32 is 78 degrees. This makes sense because all of the sides are fairly close together, and 78 is not terribly far from there. Last step, we just use what we know about angles in general. I want to double check and make sure everything works. It looks like everything is pretty equally spaced, and it looks like that's the case here. Now, just like with law of sines, there's an easier way and there's a harder way. This is the easier way. Even though it looks complicated here, your calculator will do all this work without you having to do much of it. This next example is where it gets a little dicey, and that's where I have three sides. You can technically pick any of the angles. I tend to, and it's just my thought, I always start with whatever the biggest side will be, because it gives me a good gauge to go by. So when I plug in my values, we notice that it's the angle that's missing. We can't just type this in the calculator because we have some multiplication, we have some subtraction, it's just not going to work. So what I want to do is I'm showing you step by step what I chose to do. What I did is I added these two together, and that's how I got 421. I did 17 squared. That's how I came up with 289. I came up with minus 420 because I did 2 times 14 times 15. Now I can't just subtract these two because this cosine of A is like a variable. It's like saying 421 minus 420x. You can't do anything with that. So what we need to do is we need to isolate the variable. To do that, we want to get rid of this first number. We want to subtract 421 from each side. Don't be alarmed that the left side is negative because if you notice on the right side, I have some negative numbers here as well. We're going to go ahead and keep solving. I eventually am going to have to do the inverse to find the angle. I can share with you right now and pretty confidently that this will be where we spend most of the time in class tomorrow is how do we start these questions. The good news, like the last problem, is we just have to do law of cosines for one step. Now that we have 72 degrees, which is the angle that's over here, it's a lot easier to solve. Sine of 72 over 17 is equal to sine of theta over 15. Again, I tend to like to go from big to small, but you can work in any order you want. When I do law of sines, you can pause and check and make sure that you got the same answer I did. I came up with 57 degrees being here. That made sense because this was the biggest side, this was the middle side, and this was the smaller side. I also noticed that 51 and 57 are closer, and if we notice, so are the side lengths. Again, this will probably be the harder one, and I anticipate spending several days on law of cosines because it does take a little bit extra time, but by watching this video, you've kind of primed your brain to be ready to go. Just as a quick recap, this is what we followed for each question. Step 1, law of cosines. Step 2, law of sines. And step 3, subtract for the missing angle. I'd like you to give a chance trying your turn now. This first one matches example 1, and again, just like law of sines, I broke down what you should do and in which order. We will work on being comfortable with the order a little later. If all you can get done is this first example, that's totally fine. This is the one that we'll need to spend more time on.